All right, I gave you a polynomial function here and a graph. Okay, we're going to answer these 8 questions off to the side. How many terms are there? 3. Where'd you get that from, the graph or the equation? The function, right? So there are 3 terms, 1, 2, 3. What's the degree of the function? 3. Where'd you get that from? Highest exponent. Yep. What's the leading coefficient? 4. Where does that come from? The number with the highest degree. Yep. I'm going to skip end behavior and turning points for now. Go to number 6. X-intercepts. How many are there?
Oh, this from yesterday?
3. Yep. There are 3 x-intercepts. How do I write those? 0, 0 is 1. What's the other? 4, 0.
And then I put 5.5.
Yep, I would accept that. 5.50. Okay. Now I'm going to go back up to end behavior. Okay. What does end behavior mean? What are we looking at?
Like the last part where it changes.
Right. We're looking at the far left side end behavior and the far right side end behavior. So remember we talked about as x goes to infinity. Is infinity to the left or to the right? Positive infinity is to the right. What's happening to y as we're moving on the right of the graph?
It goes up.
It's going up, so that means y is also going to infinity. Okay. The other option is as x goes to negative infinity, or as x is going to the left, what is y doing?
Goes down.
Y goes down, so that is negative infinity. Okay. Turning points. How many turning points do we have?
3.
We have 2 turning points, right? Here and here. Turning points are when it goes from decreasing to increasing or vice versa, increasing to decreasing. Okay? So this turning point right here, how can I name that? What do we name them by?
1.
That's the first turning point. Before that, when we were naming increasing and decreasing, remember we named it off of the x-axis? Same thing that I want to do here. What's this x value? X equals 1.5. Okay. What is this x value? Let's round it up. X equals 5. Yep. Okay, so when we write turning points, we write it the same way we wrote increasing and decreasing. We wrote it as the x values. Okay, now we can talk about minimums and maximums. Those relate to the turning points. So this turning point right here, is that a minimum or a maximum? Sorry, can you see that? This one right here, minimum or maximum? That's a max. This one is a min. Okay, so my minimum is it x equals 1.5 or x equals 5? For my minimum. 5. X equals 5. The maximum is x equals 1.5. See how the turning points and the mins and maxes go together? Okay. Find the notes that you just picked up on your way in. Okay, we are going to look at this right here. I want you to simplify this. What operation is happening in the middle? Addition. So does that change anything? No, we can just take the parentheses away. We rewrite. So we have 3x plus 2 plus 7x minus 4. What do I do from here to simplify? Add what together? Like terms, right? 3x plus 7x is 10x, and then 2 minus 4, negative 2. That's my final answer. Okay? Looking at that next question, what is the degree of this function?
Wait, no, second. 0. 1.
Right. What is technically the exponent of that x?
1.
A 1, so our degree is 1. Is it in standard form? It is. How do we know if it's in standard form?
Because it's like the number you write.
Right. It goes by the exponents, right? So it's highest exponent all the way to the lowest or the constant, right? I know it's not on there, but what is my leading coefficient? 10. Yep. Today we're going to be talking about adding and subtracting polynomials. It's the same thing that we just did right there, but what's a polynomial?
More than 1.
More than more than two terms, right? That right there, what we just combined it and added, that was a binomial. Now we're going to do polynomials, but it's the same idea, okay? So I want to look at this example right here. This one's not in your notes. If you want to write this down in your margins, you can, okay? First, you need to understand what operation is in the middle. What operation is in the middle here? Addition. Just like before, does addition change anything? No. So we just rewrite without the parentheses. 6x cubed plus 4x plus x squared minus 7 plus 2x cubed minus 8x squared plus 3. All I did was rewrote. Nothing changed. I just took out the parentheses. What do I do from here then?
Combine like terms.
Combine like terms. My answer, I want it to be in standard form. So what should we combine first?
The x3.
The highest exponent, right? So my highest exponent is x to the third. So what like term is common with 6x to the third? 2x to the third. How did you know those were common?
Because the 3.
Both x to the third. Yep. So 6x to the third plus 2x to the third. 8x to the third. Yep. Once you have taken care of them, I want you to cross them out so you don't have to look at them anymore. Okay? Because these can get a little messy. What would my next term be?
2.
X squared. What's a common term of x squared?
8x squared.
Negative 8x squared. What number is technically in front of this x squared? A 1. So we have 1x squared minus 8x squared.
7x.
Minus 7x squared. Cross it out. What's next?
Plus 4x.
Yep. Does 4x have a like term? No. So what do I do with it?
Just add it.
I just leave it. Yep. Leave it as is. And then what is left?
7.
I have negative 7 plus 3. Negative 4. Two things to check when you're done. Is it in standard form? Yes or no? Yes. And is it in simplest form? Meaning, do we have any more like terms? No. So we are done. That is my final answer. Okay. We're in standard form and it's in simplest form. I want to look at that same problem, but I want to look at it with subtraction. Okay. So I have 6x cubed plus 4x plus x squared minus 7 minus 2x to the third minus 8x squared plus 3. Same problem that we did before with addition, but this time we're looking at it with subtraction.
The last one.
Right, so what operation's happening this time? Subtraction. What does that change?
This line.
The signs of the first or the second?
Second.
The second, yep. So what I would do is I would go through and write positive 2 turns to negative 2. Negative 8 turns to positive 8. Positive 3 turns to negative 3. Okay, now we can rewrite without the parentheses. So I have 6x to the third plus 4x plus x squared minus 7 minus 2x to the third plus 8x squared minus 3. Correct. Everything in the first parentheses stays the same. Only the second one changes. So what do I need to do next?
Simplify.
Simplify. What needs to go first?
6x squared cubed.
X to the third and it's like term. Yep, 6x to the third minus 2x to the third.
4.
4x to the third. Cross them out. What should come next?
X plus 2. No, x squared.
X squared plus 8x squared is
9.
9x squared. Cross them out. What comes next?
4x.
Yep, does 4x have a like term? Nope, so we just leave it how it is. And then what's last?
3 and
Negative 7 minus 3 is negative 10. Check two things. Are we in standard form? Yes. Are we in simplest form? Yes. That is my final answer. One more thing to talk about, and that is a problem that looks a little like this. Okay. What do you notice about this problem compared to what we've been working with? What do you notice?
As a 2 exponent,
Y.
Yeah, like add a Y.
Yep, it has two variables, right? Okay. Let's focus on this first. We always want to see what operation's happening. What operation's happening? Subtraction. What does that do?
Makes all the ones on the left or right side switch.
It switches all the signs in the second parentheses, right? So positive 2 turns to negative 2. Positive 3 turns to negative. Negative 2 turns to positive. What can I do once I've done that?
Combine like terms.
Right, I can even rewrite next. Okay, so without parentheses, I have 3x squared y squared plus 2xy squared plus 6x squared, and then minus 2x squared y squared minus 3xy squared plus 2x squared. Again, we have two variables we're looking at. So when you're looking at two variables, there's no such thing as standard form. Okay, so let's just focus on that first one here. What is a like term of 3x squared y squared?
Negative 3x y squared.
Negative 2.
Oh, wait, no.
Negative 2x squared y squared. Why are those like terms?
So they have the same like ending part.
They have the same variables and the same exponent. So x squared y squared is a like term with x squared y squared. Okay, so if I combine those, what's left?
X to the fourth power and y to the
Ooh, I like how you said that. Since it's a like term, so if we combine 2x plus 3x, what is my answer here? 5x. Did we add the two exponents together? No. Since it's a like term, these are going to stay the same. Okay? Now let's focus on 2xy squared. What's a like term of that? Negative 3xy squared. So it's 2xy squared minus 3xy squared.
negative x y squared.
Negative xy squared. What's next? 6x squared plus 2x squared is 8x squared. When you have multiple variables, you just need to check, is this in simplest form?
Yeah.
Yes, there's no more like terms to combine, so it is in simplest form. Don't worry about standard form. Okay? All right, this is what your 4A looks like. What do we need to do first? What do we need to understand first?
It's the positive.
Yep, what operation's in the middle? Since it's addition, what do we do?
Nothing.
Nothing. We just rewrite. We have 4a to the fourth minus 6a cubed minus 3a squared plus a plus 1, big breath, 5a cubed plus 7a squared plus 2a minus 2. What do I do once I have all of that rewrote? Combine like terms. What should I keep in mind when I'm combining like terms? Like, how do I know what to do first?
Look for the biggest number.
Yep, let's work with standard form. So what's my biggest, or what's my highest degree? 4. Does it have a like term?
No.
No, so I'm just going to write 4a to the fourth. Cross it off. What's my next highest degree?
Negative.
Yep, a to the third. Is there another one? Yep. Negative 6a to the third plus 5a to the third.
Negative 8 to the third.
Negative a to the third. Cross out. What's my next highest?
3a squared.
3a squared and
7a squared.
7a squared. Negative 3a squared plus 7a squared.
7a squared.
Watch out for negatives. Yep, positive 4a squared. Next we have a plus 2a.
3a.
3a. And then we have 1 minus 2.
Negative 1.
Minus 1. Two things. Are we in standard form? Are we in simplest form? Yes. All right, what do we need to recognize first on B? It's subtraction in the middle this time. What does that mean?
Change second signs.
Yep, change the second signs. Positive 3 turns to negative 3. Negative 9 turns to positive. Positive 7 turns to negative. Now we can rewrite. Does anything happen with the first? Nope. So we have 2a squared b squared plus 3ab squared minus 5a squared b minus 3a squared b squared plus 9a squared b minus 7ab squared. What do I do next? combine like terms. 2a squared b squared goes with
3a squared b squared.
negative 3a squared b squared. What do I get when I combine those?
Negative a squared b squared.
Negative a squared b squared. Next.
AB squared.
Yep, we're just going to go in order. Yep, and then 3ab squared minus 7ab squared.
That'll be negative 4.
Negative 4ab squared. And then we have negative 5a squared b plus 9a squared b. Positive 4a squared b. Are we in simplest form? Yes. Do I care about standard form? No. Okay. Looking at that habits of mind question on your notes. Or sorry, when can you combine two terms using addition and subtraction? Like, how do you know you can combine them? How do you know they're like terms?
So it has the same exponents and the same like
Starts with a V.
variable.
Variable. It's the same variable with the same exponent. Okay? So, looking at that, can I combine 6x squared plus 3x cubed?
Yeah.
Can I combine those two?
No,
Why not?
because they don't have the same exponent.
They don't have the same exponent. Can I combine 6x squared with 3x squared? Yes, because they are the exact same variable and exponent. I'm going to ask you one more thing. Can I combine 6x squared plus 3y squared? Why not?
Because they have the y.
Right. Are x and y the same thing? No, so you cannot combine those. Okay, good. What